So here we're going to do an initial value problem. Second derivative of x plus 16 times x equals cosine of 4t with our function x of 0 at 0 and x prime of 0 at 1. And we're not going to use partial fractions. We are not going to use partial fractions.
Ooh, this is fun.
I hope so. So let's see if we can do this. The Laplace transform of the second derivative is s squared times the Laplace transform of, oops, I shouldn't call that y, I should call that x. And this one too. And so we would wind up factoring out the s squared plus 16, and that's s times 0 from this initial condition, and that's minus 1 from this initial condition. So, and of course the Laplace transform of cosine of 4t is s over s squared plus 16. So simplifies y of s, x of s times s squared plus 16 equals 1 minus s over s squared plus 16. And finally, if you divide by both sides by s squared plus 16, you wind up with x of s equal to 1 over s squared plus 16, that's from this term, and then s over s squared plus 16 squared. Well, this happens to be the same as 1/4 of 4 over s squared plus 16. The reason why I did that is because we know what the transform of, or inverse transform of this is, and I needed it to be like that. Now, remember the one we just did 2 problems ago, where we get 2 times k times s over s squared plus k squared squared, and that's the Laplace transform of t times sine of k times t. Oh, look what we have here. We have 2 times k times s over this if we were actually multiplying it by 8 and then dividing it by 8. But we needed that because this is the transform of t times cosine of, wait a minute, I gotta go back, I think it was t times sine of 4t. Yes, t times sine of 4t. So why is that handy? Well, then our x of t would be 1/4 of this, which is 1/4 sine of 4t. See, that's a 4. If that was an s, it'd be cosine over here, but it's not. And then plus 1/8 times t times the sine of 4t, and that's from the thing we just found up here. By the way, I'm sure that's in most Laplace transform tables somewhere, and we actually just derived it with this problem. So how about that for nice? And that is the solution in just a few steps. And we did avoid, as you noticed, the partial fraction decomposition.
I sincerely hope so.
Well, great.